Ever wondered why we care so much about the weather in space when we're all the way down here on Earth? Well, our curiosity is fueled by the vast mysteries of space that are yet to be unraveled. Among these enigmas is the concept of space weather. But don't be fooled by the term weather. It's not about wind, rain, or snow like we experience here on Earth. Space weather is all about the particles and energy that the sun emits. Imagine the sun as a giant ball of gas constantly churning, producing an energetic outflow called the solar wind. Now, this solar wind is more than just a breeze. It's a stream of charged particles and magnetic fields that carry energy across the solar system, affecting everything in its path. From the furthest planets to the very satellites orbiting our Earth, everything gets a taste of this space weather. So space weather is all about these solar particles and their journey across the cosmos. But why should we care? Well, it turns out this seemingly distant space weather can have some pretty significant effects right here on Earth. Now you might be wondering, what are these effects exactly? For starters, the solar wind, a stream of charged particles released from the sun, interacts with the Earth's magnetic field. This interaction results in breathtaking displays of light in the sky, known as the northern and southern lights, or the aurora borealis and aurora australis. But it's not all just beautiful light shows. Space weather can also wreak havoc on our modern technology. It can disrupt satellite communications, making your GPS go haywire or causing your favorite TV show to lose signal. It can even impact power grids, leading to blackouts in extreme cases. So space weather isn't just a distant spectacle, it can directly influence our daily lives. Now that we know why it matters, how do we go about understanding this space weather? To comprehend the complex dynamics of space weather, we rely on a symphony of technological advancements. Space-based observatories like the Solar Dynamics Observatory keep a watchful eye on the sun, capturing high-resolution images and data of solar activities. Simultaneously, ground-based instruments, such as magnetometers and ionosondes, measure the Earth's magnetic field fluctuations and ionospheric conditions to provide real-time space weather data. These tools act as our eyes and ears in the cosmos, constantly monitoring the sun's behavior. Scientists then use this wealth of data to study solar activities like solar flares, coronal mass ejections, and geomagnetic storms. Sophisticated computer models help us understand and predict these phenomena, enabling us to anticipate space weather events and their potential impacts on Earth. Through these tools and technologies, we're constantly learning more about space weather and how to predict its impacts. Understanding space weather is one thing, but how do we prepare for its effects? Good question, and one that many scientists and engineers tackle every day. There are several measures taken to protect our infrastructure from the impacts of space weather events. One of the most crucial is the development of early warning systems. These systems detect incoming solar storms, giving us valuable time to prepare and protect our technology. And it's not just about early warning. Efforts are also underway to harden our power grids and satellites against these events. By making these systems more robust, we can ensure they remain operational even during severe solar storms. These preparations are not only vital to our modern lifestyle but also to our safety. They help us to mitigate the potential risks and impacts of space weather on our everyday lives. So, while space weather may seem like a remote concept, it's something we actively study, prepare for, and deal with in our everyday lives. Remember, we're all more connected to the cosmos than we might realize.